The Air Force's premier air superiority fighter versus the military's newest multi-role stealth jet. Both aircraft represent decades of engineering advancement and billions in taxpayer investment. When you put the F-22 Raptor against the F-35 Lightning II in a head-to-head dogfight scenario, the outcome isn't what most people expect. This is the F-22 Raptor versus F-35 Lightning II dogfight analysis you've been waiting for. We're breaking down actual performance data, real pilot testimonies, and classified engagement scenarios that were recently declassified. By the end of this video, you'll know exactly which aircraft dominates in air-to-air combat. Fighter pilots don't debate hypotheticals. They study engagement envelopes, missile ranges, and radar signatures because their lives depend on understanding these aircraft inside and out. The F-22 and F-35 were built for different missions, but recent conflicts have shown they're increasingly operating in the same airspace. We're examining 3 distinct combat scenarios: beyond visual range engagements at 40+ miles, within visual range combat from 10 miles to merge and close-in dogfighting where pilot skill and aircraft performance determine survival. Each scenario reveals different advantages that could determine which pilot makes it home. The F-22 Raptor entered service in 2005 with one mission: establish and maintain air superiority. 2 Pratt & Whitney F119 engines produce 35,000 pounds of thrust each, pushing this 43,340-pound fighter to Mach 2.25 at altitude. The Raptor supercruises above Mach 1.5 without afterburners. That means maintaining stealth while covering ground faster than any other operational fighter. The thrust vectoring nozzles give the Raptor maneuverability that defies physics. These engines redirect thrust up to 20 degrees in the pitch axis. The aircraft can point its nose independent of its flight path. In close combat, this translates to angles no other fighter can match. Internal weapon storage maintains an extremely low radar signature while carrying 6 AIM-120D AMRAAMs and 2 AIM-9X sidewinders. The APG-77 ASA radar tracks multiple targets beyond 100 miles while remaining undetected by enemy radar warning receivers. Production ended at 187 aircraft. Each Raptor represents technology so advanced that export remains prohibited by federal law. Congress banned foreign sales to protect classified capabilities. The Raptor moves air. Raw kinetic performance defines every design choice. The F-35 Lightning II approaches air combat differently. Where the F-22 relies on superior kinematic performance, the F-35 leverages information dominance. Multiple sensors create a complete tactical picture that no other aircraft can match. The distributed aperture system consists of 6 infrared cameras providing real-time spherical coverage. Pilots describe seeing through the aircraft itself. Threats appear directly on helmet visors regardless of aircraft orientation. This system detects and tracks incoming missiles from any direction simultaneously. The APG-81 ASA radar looks forward, while additional sensors provide the 360-degree awareness. Electronic surveillance measures, infrared search and track, and communications intelligence create a sensor fusion network that processes threats automatically. Electronic warfare capabilities extend beyond traditional jamming. The F-35 can disrupt enemy communications, spoof radar systems, and coordinate electronic attacks across multiple aircraft. The Odin sustainment system monitors every component in real time, predicting failures before they occur. Single Pratt & Whitney F-135 engine produces 43,000 pounds of thrust with afterburner. Maximum speed reaches Mach 1.6. Combat radius extends beyond 600 miles depending on configuration. 3 variants serve Air Force, Navy, and Marine Corps requirements with over 900 aircraft delivered worldwide. The Lightning moves data. Information warfare defines its operational advantage. Modern air combat occurs at ranges where pilots never see each other. Weapons release happens at 40 to 80 miles. Advanced missiles guide themselves to targets using multiple sensors. The aircraft that detects, identifies, and engages first typically wins. F-35 sensor fusion provides earlier target detection in cluttered environments. Multiple sensor inputs create target tracks that individual systems might miss. The aircraft automatically correlates data from radar, infrared sensors, electronic surveillance, and data link information from other platforms. Both aircraft maintain low radar signatures from the front aspect. Stealth effectiveness varies with viewing angle and radar frequency. The F-22's design prioritizes frontal radar cross-section reduction for penetrating missions. F-35 stealth optimization balances signature reduction across multiple threat frequencies while accommodating its multi-role mission requirements. Engagement advantage depends on initial geometry, electronic warfare environment, and supporting assets. Neither aircraft operates alone in realistic scenarios. The question becomes which platform provides better information to make that critical first shot count. In this phase, the F-35's sensor advantage could prove decisive. Better information beats better performance when you can't see your enemy. When aircraft close to visual range, aerodynamic performance and pilot skill become decisive factors. The F-22's thrust-to-weight ratio of 1.26 exceeds the F-35's 0.87. Superior acceleration and climb performance matter when missiles start flying. Thrust vectoring allows the Raptor to maintain control at angles of attack that would stall conventional fighters. The F-35 lacks thrust vectoring on Air Force and Navy variants. Only the Marine Corps F-35B has vectoring capability for vertical landings. F-35 pilots compensate with superior situational awareness. The helmet-mounted display system presents targeting information regardless of aircraft attitude. Pilots can target and engage threats while maneuvering aggressively. They maintain awareness of multiple contacts simultaneously. Both aircraft carry AIM-9X Sidewinder missiles capable of off-bore sight targeting beyond 90 degrees. The F-22's superior maneuverability provides better weapons employment opportunities. The F-35's sensor fusion ensures pilots maintain contact with all threats during defensive maneuvering. Training exercises reveal consistent patterns. F-22s dominate one-versus-one engagements where raw performance determines outcomes. F-35s perform better in complex scenarios with multiple threats and electronic warfare. When the merge happens, physics starts winning over information. Traditional dogfighting requires sustained turning performance, energy management, and precise weapons employment. The F-22 demonstrates clear advantages in all three areas. Superior thrust-to-weight ratio maintains energy during defensive maneuvering. Thrust vectoring provides instantaneous nose pointing for weapons employment opportunities. Sustained turn rate at military power exceeds 20 degrees per second. Instantaneous turn rate reaches 28 degrees per second with thrust vectoring engaged. These performance margins translate to tactical advantages in close combat scenarios where milliseconds determine survival. F-35 pilots acknowledge kinematic disadvantages while emphasizing sensor advantages. Advanced targeting systems provide earlier threat detection and superior weapons employment capabilities. The aircraft's computer systems reduce pilot workload. Pilots focus on tactical decision-making rather than aircraft management. Recent red flag exercises demonstrate both aircraft excel in their designed roles. F-22s consistently achieve high kill ratios in air-to-air scenarios. F-35s successfully complete strike missions in defended airspace, where other aircraft fail to penetrate enemy defenses. Head-to-head comparisons rarely reflect realistic combat scenarios. Aircraft operate as part of integrated packages supporting broader mission objectives. In a phone booth fight, the Raptor's kinematic advantages become overwhelming. Modern combat aircraft operate in dense electromagnetic environments. Electronic warfare capabilities determine which systems function effectively when enemies attempt to jam, spoof, or hack aircraft systems. The F-35 was designed with these threats as primary considerations. Advanced electronic warfare systems can disrupt radar guidance, spoof missile seekers, and jam communications across multiple frequency bands simultaneously. The F-35's distributed processing allows rapid adaptation to new threats through software updates rather than hardware modifications. Information sharing multiplies combat effectiveness exponentially. 4 F-35s share sensor data automatically. Combined situational awareness exceeds individual aircraft capabilities. This networked approach compensates for individual performance limitations through superior information management. The F-22's electronic systems remain highly classified. Known capabilities focus on penetrating enemy airspace undetected rather than disrupting enemy systems. Different approaches reflect different mission priorities established during each aircraft's development phase. Cyber warfare represents the next frontier in air combat. The F-35 was built for this environment. The F-22 wasn't. Combat effectiveness extends beyond individual aircraft performance. Maintenance requirements, operational availability, and deployment flexibility determine how many aircraft reach the fight. Mission capability rates remain critical factors. F-22 operations require specialized facilities and maintenance procedures. Stealth coatings demand climate-controlled hangars and extensive restoration after each flight. Operational availability typically ranges between 50 to 70%. Complex maintenance limits deployment flexibility. F-35 design emphasizes maintainability and global operations. Automated diagnostics reduce maintenance man-hours. Predictive systems prevent failures before they occur. Availability rates target higher percentages with lower maintenance requirements than legacy fighters. Cost per flight hour reflects these operational differences. F-22 operations cost significantly more than F-35 operations across all mission types. Sustainment costs continue evolving as both programs mature. Numbers matter in combat. Having more aircraft available beats having better aircraft unavailable. The F-35's electronic warfare suite represents a generational leap beyond traditional jamming. The AN/ASQ-239 Barracuda system can identify, locate, and attack enemy radar systems automatically. This is not defensive jamming. This is offensive cyber warfare at the speed of light. Electronic attack modes can blind enemy radars, feed false targets to missile systems, and disrupt command networks. The aircraft becomes a flying electronic warfare platform while maintaining its stealth signature. Enemy forces might never realize they're under attack until their systems stop functioning. The F-22's electronic systems focus on survival rather than attack. Low probability of intercept radar modes and advanced countermeasures protect the aircraft from detection and engagement. Different philosophies reflect different design eras and mission requirements. Future conflicts will be fought in contested electromagnetic environments. The side that controls the electromagnetic spectrum controls the battlefield. Electronic attack capability could determine air superiority before missiles launch. F-22 pilots describe flying the Raptor as pure fighter pilot aviation. The aircraft responds instantly to control inputs. Thrust vectoring creates impossible maneuvers. Energy management becomes intuitive. The Raptor feels like an extension of the pilot's will. F-35 pilots emphasize the aircraft's intelligence. Computer systems handle complex calculations automatically. Sensor fusion presents simplified tactical pictures. The pilot becomes a battle manager rather than an aircraft manager. Decision-making speed increases dramatically. Both pilot communities respect the other aircraft's capabilities. F-22 pilots acknowledge the F-35's superior sensors and networking. F-35 pilots respect the Raptor's unmatched kinematic performance. Professional assessments focus on mission requirements rather than aircraft superiority. Training emphasizes each aircraft's strengths while mitigating weaknesses. F-22 training focuses on air-to-air tactics and penetrating strike missions. F-35 training emphasizes multi-domain operations and information warfare. The pilot remains the most important component in either aircraft. In air-to-air combat, aircraft performance advantages depend entirely on engagement parameters. The F-22 Raptor dominates scenarios requiring superior kinematic performance. High-altitude intercepts, close-in, dogfighting, and penetration of heavily defended airspace play to Raptor strengths. No operational fighter matches its combination of speed, maneuverability, and stealth. The F-35 Lightning II excels in complex threat environments where information dominance determines success. Superior sensors, networking capabilities, and electronic warfare systems provide advantages in scenarios involving multiple threats, surface-to-air missiles, and coordinated enemy tactics. Both aircraft represent different approaches to air superiority. The F-22 achieves dominance through superior performance. The F-35 achieves dominance through superior information. Neither approach is inherently better. Mission requirements determine which approach succeeds. Future air combat will likely emphasize information warfare over kinematic performance. Stealth, sensors, and electronic attack matter more than speed and maneuverability. The F-35's design philosophy anticipates this evolution. The F-22's design reflects previous priorities. Combat aviation relies on integrated packages where different platforms contribute specific capabilities. The F-22 establishes air superiority. F-35s provide persistent surveillance and precision strike capabilities. Combined operations maximize each aircraft's advantages while minimizing weaknesses. Both programs represent American technological superiority pursuing the same objective, ensuring American forces control the skies above any battlefield. The answer to which wins depends entirely on the mission parameters and threat environment they face. In a pure dogfight, bet on the Raptor. In everything else, bet on the Lightning. Next week, we're analyzing how the F-22 Raptor performs against Russia's newest Su-57 Felon fighter. Recent intelligence assessments reveal capabilities that challenge everything we thought we knew about fifth-generation air combat. Subscribe for more detailed aircraft analysis and let us know which matchup you want to see next. The comment section debates get more intense than afterburner reheat.